So this is the scientific method. The scientific method is going to be a series of steps that we're going to use in order to evaluate a specific phenomena. So first we're going to make observations. And again, I want to reiterate that the different definitions and steps of the scientific method has been highly tested since I've been a student, so I can guarantee it'll show up on an exam. But observation, this is just watching the world in a natural way. I've listed here two different forms of observation. One is an invention of a microscope. It allowed us to observe things that was not possible to see with the naked eye. Another example would be attending conferences and meetings. So, for example, if I was highly interested in hematology and oncology as a medical student, if I was to go to a colleague's conference, hematologist-oncologist conference, and I studied his findings through an experiment, and I came back and developed my own experiment, this would be a form of observation. A hypothesis, again, the definition is very important, specifically an informed statement that can be tested in a manner suited to the process of science. It uses a fancy word called inductive reasoning, which is, it's not really that important, but for our purposes, it's just utilizing their specific observations to develop a general idea or hypothesis about observed phenomena. Not important. So once we have a hypothesis, we have an informed statement, we're going to test it, right? We're going to develop an experiment. It's a series of procedures to test the hypothesis. It's important that when we develop a proper experiment that we're going to have these four things. And again, these four things are important to know. It's the factor of the experiment being tested. That's an experimental variable, right? It's thing that is subject to change variable. It's the factor of the experiment being tested. The response variable is what do we expect to occur due to the experimental variable, right? It's the response. It's the response variable. Then you have the test group. That's actually the group being tested, and the control group. These are the groups not exposed to the experimental variable. So again, experimental variable. It's the factor of the experiment that we're actually testing. The response variable. What do we expect to happen due to being exposed to experimental variable? Then we have the two groups that we're going to experiment on, the test group and the control group. The control group does not, they're not exposed to the experimental variable, whereas the test group, they are exposed to the experimental variable. So then after we design our experiment, then we're going to have data. Data is going to be plotted in graphs or tables, and we'll have results, and we will either accept or reject our hypotheses. So an example here, so we made our observation. Our observation is stomach and duodenal ulcers are due to a bacterium, H. pylori. And we are going to say, we're going to make an informed statement. We're going to say, this antibiotic B is a better treatment for ulcers than antibiotic A. Well, how would we test this, right? So we're going to have three different subjects. We're going to have a control group who receives a placebo. They're not going to be exposed to the antibiotics. Then we're going to have two test groups, ones who receive antibiotic B and ones who receive antibiotic A. And then we're going to see our data. The data here says that antibiotic regimen B improved the ulcers by 50%. Antibiotic regimen A only improved by 33%. And then, of course, the control, they didn't receive either antibiotic, so we expected no change in their ulcers, no improvement. And we can say, do we accept our hypothesis? We said that antibiotic B is better treatment for ulcers than antibiotic A. So we made that our conclusion here, as you can see. Science and the challenges facing life. So scientific investigation is the basis for our technological advances. So in our book, we have the definition of technology, and that actually may show up on an exam in the future, so I would know that specific definition. But due to the development of science, or due to science and the technological advances, we are also having consequences or ramifications. like I said here, humans are altering organisms and ecosystems to address the needs of human society. Um, Climate change. So, climate change refers to the changes in the normal cycles of the Earth's climate that may be attributed to human activity. Um, so, excess carbon dioxide production, or CO2, um, can cause something called global warming that we will discuss later on. The destruction of trees. Trees are responsible for the production of oxygen and the recycling of carbon dioxide. So, destroying these trees may um, lead to changes in the ecosystem, changes in organisms, but knowing the definition is primarily the most important thing. So, how does climate change work? So, climate change, like we said, is primarily due to an imbalance in the chemical cycling of the element carbon. Normally, carbon is cycled within the ecosystem, right? Remember, we said that trees were responsible for the production of oxygen and the recycling of carbon dioxide. However, due to human activity, more carbon dioxide is being released into the atmosphere than is being removed. So here I found this statistic in your book. In 1850, there was a carbon dioxide level of 280 parts per million, and today we see that it's 415 parts per million. So again, we can see that there has been some excess CO2 production. Like I said previously, this increase in carbon dioxide in the atmosphere is causing a rise in the temperature, called global warming. Again, more important to know the definition than anything else. These gases allow the sun's rays to pass through, but they absorb and radiate heat back to the earth, a phenomenon known as the greenhouse effect. So again, knowing the greenhouse effect, knowing global warming, knowing climate change, all important concepts. So biodiversity, this is just the total number and abundance of species. So climate change and global warming has been causing less biodiversity, um, and can eventually lead to something called extinction. Um, it's a term used when describing the death of a species in a large category. Of course, everybody knows about the extinction of dinosaurs. Um, Primarily, the species that are worried about extinction include some primates, birds, and amphibians. So here I have an example. Not important to memorize this slide or anything like that, but two of the most biologically diverse ecosystems includes the tropical rainforests and the coral reefs. You may have heard about the Amazon rainforest and the coral reef. So these ecosystems have they house several, I would say, hundreds of thousands of different organisms. And as we are destroying the coral reef and the tropical rainforest, we are losing some of these important organisms. Skeletons of sea animals called corals. Reefs provide a habitat for animals including sponges, snails, crabs, lobsters, etc. So the destruction of healthy ecosystem has many unintended effects. It's important. So pretty much from these slides, just knowing that how are we resulting in less biodiversity? Essentially, it's through the destruction of healthy ecosystems. Emerging and re-emerging disease. Emerging disease are diseases that are relatively new to humans. COVID-19, this is important. This is an example of an emerging disease. This led to a global pandemic, as you guys are probably still experiencing the consequences of this. I know I've been definitely affected by this within healthcare and within my family as well. Other examples were avian influenza, swine flu, and SARS, severe acute respiratory syndrome. And then we say, why do we have these emerging disease? Could be just due to changes in human behavior and technology. It could be exposure to contaminated animals. I know that with COVID-19, it was thought that it was due to ingestion of a horseshoe bat in China. And then example of technology resulting in development of a disease. This is the book gives an example: Legionnaire's disease. It emerged in 1976. This was due to a bacteria that people developed pneumonia after bacterial contamination within a hotel. So these people would go to a hotel and stay, and then they would come home and they would have pneumonia-like symptoms, and they were wondering why, and it was just due to bacteria living within the water cooling system within the air conditioner. So, but again, the most important thing from this slide, knowing that COVID-19 is an example of an emerging disease, and knowing where do emerging disease come from, and it's just due to changes in behavior, human behavior, technology, and ingestion of contaminated animals. So this has been chapter 1. I have a few questions and quizzes. I think that quizzing yourself is very important, so I've created some quizzes for you guys. Just kind of quiz yourself. I'll upload those. I had them built into one version of the PowerPoint that I think may be uploaded for you guys, but you can kind of go over those yourself. Again, if you have any questions, feel free to reach out to me. I'm never too busy for you guys. I try to emphasize the things that I want you to know, the things that are important. The 3 things that I would focus on today is knowing the characteristics of life, knowing those, knowing examples, knowing your definitions for that I've listed, and then just knowing about climate change and global warming. Those are the 3 things that I would really focus on. So again, if you have any questions, shoot me an email. I'm here for you guys. So thank you all.